Good afternoon. This problem is my solution for the sample problem of theory of structures. So this problem consisted of two requirements, which is the maximum deflection, which is located at this distance from the applied load, and calculation of the value of maximum deflection, which uses the modulus of elasticity of 200,000 Newton millimeter squared and the inertia of 60 times 10 to the power of 6 millimeter to the power of 4. So in this FBD, this will be characterized by the equation of inertia I, which is elasticity times inertia y is equals to m minus m divided by its time x. Since to get the values, which is the required values, we will use double integration method. So we will double integrate this. So this will become, so I will directly get the value since it will become measuring. This will become mx minus m over 2l x squared, which is the power brought down to that denominator. So the 2 will be brought down to the denominator, which makes it 2l plus c1. So c1 for the first integration. So for the third, we will make it m to the power of 2x squared. Again, the numerator of the x squared, which we have integrated, is brought down to the denominator and applied to the other terms. So m over 6l x squared, x cubed rather. So you make it the x for the next term, we'll make it the x into plus 1, so it will be 3. And 3 multiplied with 2l of the denominator, which will make it xl. Plus c1 integrated, which will become c1x plus c2. So we will substitute it with x is equals to 0 and y is equals to 0 to get our c2 and c1. So when we use the 0 value substituted to x, we'll make our terms 0. So every terms that there are x, we will make it as 0. So this will become 0, x is equals to 0, is equals to 0 minus 0 plus 0 plus c2, which makes c2 our last value that is not 0. Then transpose it, so our C2 will become 0. So we already have the value of our C2. Next is our C1. So let's make it that x. So our value sa x is we have the L. So let's make it that L is equals to H, or x is equals to L, and again y is equals to 0. So we have 0 is equals to m over 2. Our x substituted to L, so we'll make it L squared minus m over 6L. Again, our x substituted by L, so we'll make it L cubed plus C1x supposedly, so we'll make it C1L. So our C1, for the value of our C1, manipulate, so our value for the C1 is negative m L over 3. So, to solve for the distance which has the maximum deflection, we will use the second equation, second division in here, which is E I y prime mx minus m 2l x squared plus c1. So let's get it. E I y prime is equals to m x minus m 2l x squared minus m l over 2 by 3, sorry, equals to 0. So, as you notice, there is minus ml over 3 in here, which is the value of our C1. Since in our second equation in here, the integration, there is a C1. So, this is the value substitution for C1. So, to proceed, we will simplify this. So we can proceed to the quadratic equation. So to simplify, we will multiply it by 2l times 3. So let's do it like this. Times 3 equals to 0 times 2l times 3. So this will be cashed out as is 0. So let's solve. The result for this multiplied by 2l times 3 will be 6l and x minus 3 and x squared minus 2m l squared. So this is u rather over m multiplied by m. So we will cash out the m. This will result to 6 by 3x squared minus 6 lx plus 2l squared. So we have arranged, we still have already arranged this to suit our quadratic equation. Next is to substitute these values on the quadratic equation, which is x is equals to 6l. So plus minus square root of negative 6l squared minus 4 times 3 times 2l squared over 2 times 8, or our a is 3. So this term is our a for the quadratic equation. This will be b and c. So the result for this is 0.4226L right here, which will be substituted with our length 0.4226L is equals to, substitute the length in here, which is 7 meters, which will result to 2.62. So this is the answer for our first requirement, the deflection at length x. So I will erase this. To get our second requirement, which uses 200,000 and 60 times 10 to the power of 6 millimeter to the power of 4. Our maximum deflection. So for our maximum deflection, we will use the third equation, the last integration, which is E I y is equals to m x squared over 2 minus m over 6l x cubed minus m l over 3x. This is our C1. But on our last integration, we have an x since we integrated our C1, which makes it C1x. So again, substitute this to get our last required value is equals to 10 over 2 times 2.958, which is the result of our x, our certain distance, which has the maximum deflection, 2.958 squared minus 10 over 6 times 7. Okay. 6 times 7. Again, 2.958. All values of x, which will be substituted by 2.598 cubed minus 10 times 7 over 3 times 2.958. So this will result to 8. So calculate it, EIY is equals to negative 31.43 kilonewton per cubic meter. And now we will multiply it with our EY. This value should be multiplied by our EY, which is y will remain on the other side, then negative, and then 31.43 times 10 times 1000 the power of 4 over, which is divided by our reduced elasticity and the inertia value, which is 200,000 times 60 times 10 the power of 6. So our y is 2.62 mm. So to summarize, our x is equals to 2.958 meters, while our y is 2.62 millimeter. So this is it for my sample problem in quiz 4. Thank you.
So for the next problem, we have here the structural members which from A to B, B to C, and A to C. So it has a equivalent each of its sides. So in this kind of form of FBD, we have the stress came from A to C, and the stress from B to C, which is this one right here, and have a 30-degree sides at the center. So we have W here, which is the applied load. So we are going to get the or determine the elongation formula of this FBD. Okay, so elongation of joint C. So for this one, so note that it is SAB, which will be equal to 0. So in the summation of horizontal in joint, the summation of force in horizontal, which is x equals to 0, which is AC equal to SB to C. For the vertical, I mean the summation of force in vertical, which is 0, which is will be equal to Summation of it is AC times the cos. This one 30 degree. 30 degree plus minus BC. Same goes with cos 30 degree. Note that the value of cos 30 degree in fraction form will be equal to square root of 3 over 2. So we have to simplify this one. So substitute the cos 30 with this one. So we have S AC times square root of 3 over 2, and then plus S BC times square root of 3 over 2, which is equal to 0. I mean W. So now we have to substitute the value of SBC as SAC. So SAC 3 over 2 plus SAC 3 over 2 equals double. And then add, since it is a same symbol, we have square root of 3 and SAC equals W. So that is the value of SAC. So SAC will equal to W over square root of 3 square root of 3. Since SAC is same with is equal to SBC, so SBC now for the unified unit, so we set W which is equal to 1. So UAC equals to UBC, which is equal to negative 1 over square root of 3. Now we can get I solve for the elongation at joint C, which is equal to the summation of SU1 over DC, which is equal to over 80. So negative W over square root of 3 times negative 1 over square root of 3 plus same negative 3 times negative 1 over 8. So here we can get the formula or the equation for the say by simplifying this one. So 3 times 3 we have cancel out the square, and then negative times negative is positive. We add these two terms, so we can get the value 2 times W so over 3AE, and that's how simplify the equation for the elongation of adjoint C. And that would be all, and thank you.
Hello guys, so for today's video, I will going to discuss one of the example problem of structural theory. So I have a given problem here, a prismatic beam 8 meter long is fixed at the left end and simply supported at the right end. The beam carries a uniformly distributed load of 400 kilonewton per meter throughout its length. So the question is, what is the deflection at the right end due to the uniform load when the simple support is removed? So in this problem, first we must identify or draw the FBD or free body diagram so that we can identify the given problem. So here is our prismatic beam. So this is our prismatic beam. There is a length of 8 meter and width of 400 kilonewton per meter. So this is our A here and this is our B here. So this is our reaction. So this is our given beam loading. So when the deflection at B in a simple support is removed, it will become, our prismatic diagram will become like this. So we have also a length of 8 meter and we have a weight of 400 kilonewton per meter. And here is our B and here is our A and here is our B. And this is our deflection simple support. Support is removed. And now we will solve the deflection of our problem at B when the simple support is removed. So we have the deflection at B when the simple support is removed. So we have a formula of deflection equals width times length to the power of 4 over 8 elongation of I. And since we will get the deflection, so deflection equals, our width here is equals to 400 kilonewton per meter, and our length here is equals to 8 meter to the power of 4 over 8 EI. So when we will calculate it, it will result to 204,800 over I. So this is our deflection at B when the simple support is removed. And now we will proceed to get the reaction. The reaction of deflection of our prismatic beam. So reaction at the simple support. So we have a formula of deflection, but that, we will draw this so that we can identify the given. So this is our prismatic beam. This is our A, this is our I, this is our G, and this is our deflection of U. Since we have a length of 8/3. And now we have a formula of, in order to get the reaction, we have a formula of deflection of U is equals to P, which is pressure, times the length over U. I to the power of U over 3, elimination of I. So our pressure here is equals to 1. Since we have a length of 8 meters, so we will multiply it to the power of U. And 3 EI. So when we will calculate this, it will result to 512 over 3 EI. So we will, to get the reaction and the simple support, we will divide the deflection at P when the simple support is removed and divide it to our reaction. So reaction, which is R, is equals to deflection, this is our formula, over deflection of U is equals to since we have a deflection of 204,800 divide per combination of I divided by deflection of U, which is 512. So 512 3. So when we will calculate it will result to reaction is equals to 1,200 Joule. And this is our reaction. R is equals, or reaction is equals to 1,200 kN. And that would be all. So hello guys, we have another problem of reinforced concrete, design steel and timber and construction. So here is our sample problem. So a 10-meter steel wide flange is laterally supported. The width of the wave is 700 mm and the width thickness is 1680 mm if y is 250 MPa. The question is, what is the allowable bending stress? So we have a formula of P over TW. Since our this stands for diameter, which is 700, and our TW is equals to 10, which is the 10-meter steel wide fence in our given problem. So when we calculate it, it will result to 770. And now, in order to get the Fy, so since we have 1,680 with thickness of our given problem, which is 1,680 over square root of Fy. So 1,680 over square root of Fy, which is 250. And if we calculate this problem, it will result to 106.25. Since T over TW F5. So this is 1680 over square root of Fy. Then if B is equals to 0.66 Fy, if B is equals to, now we will going to get the FB, which is FB is equals to 0.66 Fy times Fy, which is 250. And it will result to 165 MPE. And this is the answer. In order to get the allowable bit trace of our given problem, that will be our thinking.
So hello everyone, for today's video, we're going to answer some problems in this situation. So for that, we're going to read first the situation and read some questions that are required to answer. So, a prismatic beam 8 m long fixed at the left and simply supported at the right end, the beam carries a uniformly distributed load of 400 kNm throughout its length. And the problem that is required to answer is which of the following most nearly gives the deflection at the right uniform load when the simple support is removed. And the second is which of the following most nearly gives the deflection at the right end due to a unit load alone acting at the right end with a simple support removed. Lastly, which of the following most nearly gives the reaction at the simple support in Kn? And for that, we're going to write some solutions together with the FBD for us to answer these questions. So for now, we're going to write our solution to the deflection at B when simple support is removed. Simple support is removed. So, for that, we're going to write delta is equals WL to the power of 4 is over 8 AI. Delta is equals WL to the power 4 over 8 AI. So delta is equals to 400 and 8 to the power of 4 over 8 EI. So for that, we're going to use our calculator in calculating it. So, the answer for it is 204,800 over EI. And in our deflection due to the unit load at B is deflection load deflection due to the unit of B. Sorry, I forgot the unit. Due to the unit B. Due to the unit of B. So, the deflection of load due to the unit of B is delta U is equals to PL to the power of 3 is equals to 3 EI 3ei. Delta u is equals to PL to the power of 3 over 3ai is equals to 1 and a to the power of 3 3ai. So our answer for it is going to be calculated with our calculator. So 1 is multiplied by 8 to the power of 3 and our 3ai. So the answer for it is equals to, according to our calculator, which is 512 over 3ai. So for now, we're going to calculate the reaction. For that, we're going to erase it. So, our reaction which is R is equals to our delta over its delta U, which is our 204,800 over its AI, which is our previous calculation in the last video, and our delta U, which is the 512 over 3EI. So for that, we're going again to calculate it with our calculator. So 204,800 and 512. So for that, over 3 divided by 3. The answer for it is 1,200 kN. So our reaction, or R, which is represented in our solution, is 1,200 kN. So for that, this is our answer in reaction. In finding our reaction, this is the answer. So for that, we're going to make our free body diagram. And for that, we're going to erase it. So for now, in this final video, we're going to make our free body diagram. So, as you can see here at my solution, which is our previously been calculated, which is our deflection at B when simple support is removed, is 204,800 over AI, and the deflection due to the unit load at B, which is 512.3 AI, which is our final answer. This is the final answer and previously calculated and the reaction. So for now, I'm going to make my free body diagram. So So here inside, we're going to write the 400 kN PN over M. So our length for it is 8, the given in our situation. So here we put the angle A, and here we're going to put the angle B and its reaction which is R, and the given beam loading. So here, this is our first free body diagram. The length is 8 meters and 400 kN load, and this is the angle E, B, and the reaction is here. So the another free body diagram. Ito sa babi. So at the same free body diagram, the length also will be 8. And 400 kNm, and the angle is so here we put another line and the angle E and B. So the delta and the support will be removed. So delta when the support is removed. So here, as you can see, this is the free body diagram of the support when it is removed. And the third free body diagram, sorry, I forgot. We put here some delta. Here there is an arrow and 1. And here we put some angle of E. Here we put some angle of E. So delta, we put here some delta, and the length also will be 8m here, 8m the length, and the angle B will be here. So it will bend. So here will be the delta U, or the deflection of U. So due to unit load of B, at B rather. So here this free body diagram is given by beam loading. So it accordingly by the beam loading given. And here the second free body diagram is represented when the support is removed. It's going to be removed here. And here free diagram of due to the unit load at B. So as you can see, there has been changes at first free body diagram, second, and the third. And that's all. We're going to get the answer.